Integrals, product of sine and cosine functions. In this module, you will learn how to find integrals involving the product of two or more sine and cosine and both sine and cosine functions. Before we begin with integrals, let's recall some trigonometric identities. The first identity is 2 times cosine x into cosine y equals cosine of x plus y plus cosine of x minus y. The second identity is 2 times sine x into sine y equals cosine of x minus y minus cosine of x plus y. The third identity is 2 times sine x into cosine y equals sine of x plus y plus sine of x minus y. Let us use these identities to find integrals. Suppose we need to find the integral of cosine of 12x into cosine of 5x. Apply this identity to express the given integral as half times the integral of cosine of 17x plus cosine of 7x. Since the derivative of 1 over 17 times sine of 17x is cosine of 17x, the integral of cosine of 17x is 1 over 17 times sine of 17x. Similarly, the integral of cosine of 7x is 1 over 7 times sine of 7x. So, the required integral is 1 over 34 times sine of 17x plus 1 over 14 times sine of 7x plus constant c. Let's look at one more example. We need to find the integral of sine of 4x into cosine of 8x. Apply this identity to express the given integral as half times the integral of sine of 12x plus sine of minus 4x. Recall that sine of minus theta equals minus sine theta. So, sine of minus 4x equals minus sine of 4x. The integral of sine of 12x is minus 1 over 12 times cosine of 12x. Similarly, the integral of sine of 4x is minus 1 over 4 times cosine of 4x. So, the required integral is minus 1 over 24 times cosine of 12x plus 1 over 8 times cosine of 4x plus constant c. Now let's find the integral of sine x into sine of 2x into sine of 3x. First, pair any two sine functions in brackets. Now use this identity to replace the bracket. We can take 1 over 2 outside the integral. Next, multiply the bracket with the function outside it to get two integrals. First, let's find the integral of sine x into cosine of minus x. Recall that cosine of minus theta equals cosine theta. So, sine x into cosine of minus x equals sine x into cosine x. Now use this identity to express the integral as half times the integral of sine 2x. the integral of sine 2x is minus 1 over 2 times cosine of 2x plus c1. Thus, the integral of sine x into cosine of minus x is minus 1 over 4 times cosine of 2x plus c1. Now let's find the integral of sine x into cosine of 5x. Use this identity to express the integral as half times the integral of sine of 6x plus sine of minus 4x. We know that the sine of minus 4x equals minus sine 4x. The integral of sine of 6x is minus 1 over 6 times cosine of 6x. Similarly, the integral of sine of 4x is minus 1 over 4 times cosine of 4x plus c2. Thus, the integral of sine x into cosine of 5x equals minus 1 upon 12 cosine of 6x plus 1 over 8 cosine of 4x plus c2. These are the two integrals. We need to multiply by half and add a constant of integration, c, to the whole expression. Simplify it further to get the required integral as minus 1 over 8 times cosine of 2x plus 1 over 24 times cosine of 6x minus 1 over 16 times cosine of 4x plus constant c. In this module, you have learnt to find integrals involving the product of two or more sine and cosine and both sine and cosine functions.